Problem 1. Anne paints fences as her summer job. This week, she finished painting 2 of 5 white fences and 1 of 7 green fences. What is the fraction of white and green fences that Anne did not finish painting this week? A fraction is represented by a numerator and a denominator. In this problem, the denominator is the total number of fences, and the numerator is the number of fences Anne did not finish painting. Let's calculate the total number of white and green fences. 5 white fences plus 7 green fences equals 12 total fences. Anne finished painting 2 white fences and 1 green fence for a total of 3. However, the question is asking for how many fences Anne did not finish painting. Let's subtract 3 from 12 to get 9 fences not painted. Thus, our final fraction is 9 divided by 12. This reduces to 3 divided by 4. The correct answer is D. Problem 2. After 75% of a pizza has been eaten, 6 pieces remain. Assuming the pieces were of equal size, how many pieces did the pizza originally have? Let's visualize this problem. Draw a pizza with 75% eaten and 25% remaining. This 25% consists of 6 pieces. Now, one way to solve this problem is by constructing the following formula. 6 pieces equals 25% or 0.25x, with x representing the total number of pieces. Divide both sides of the equation by 0.25. The total is 6 divided by 0.25, or 24 pieces. Now, another way to approach this problem is by using the answers. 6 pieces represent 25% of a larger number. We could multiply each of the answers by 0.25 until we get 6. In either case, the correct answer is F. Problem 3. Which of the following represents 1/100th of 10%? To solve this problem, convert both numbers either to fractions or decimals, and then multiply. 10% is 1/10 as a fraction. 1/100th times 1/10 equals 1/1000th, or 0.001. Or we could convert 1/100th to 0.01 and multiply by 0.10, which is 10%, as a decimal. In either case, the correct answer is 0.001, or answer D. Problem 4. A group of N musicians practiced an average of X hours per week. One musician discovered that her practice time was recorded incorrectly and should have been T hours longer. Compared to the uncorrected average, the new practice time average for the group of musicians will be. The average is calculated by taking the total number of hours for all the musicians divided by the number of musicians. In symbolic terms, X equals total hours divided by N, the number of musicians. Now, one musician says her time should be T hours longer. What does this do to our average? Well, the new average would be the total hours plus T, still divided by N. How much longer is the new average? Let's divide N into each part of the numerator. The new average then becomes 2 fractions. Total hours divided by N plus T hours divided by N. The new average is thus the old average plus T divided by N. The new average is T divided by N hours longer. The correct answer is K. Problem 5. Pamela needs a test average of at least 84 to make a B in her biology class. If she has test scores of 80, 73, 92, and 84 on 4 of her 5 tests, what is the lowest score she can make on her 5th test to get a B in biology? The average is the sum of all the test scores divided by the number of tests. Let's add up the 4 test scores that are known. 80 plus 73 plus 92 plus 84 equals 329. Now, Pamela has to average at least 84 to make a B. What is the lowest score that she can receive on the 5th test? Looking at our equation, the average, or 84, must equal the sum of the 5 test scores, or 329 plus x, divided by 5. In this problem, x represents the unknown 5th test score. Let's solve this equation. Cross multiply. 329 plus x equals 84 times 5, or 420. Subtracting 329 from both sides gives us an answer for x of 91. Pamela needs at least a 91 on the 5th test to maintain a B average of 84. The correct answer is C. Problem 6. A store is having a special promotion and is tripling the value of cents off coupons. Let S be the price of a given box of So Clean laundry detergent in cents, and let B represent the size of the box in ounces. If a customer has a 30-cent coupon for any size box of So Clean laundry detergent, then which of the following formulas determines the price per ounce of the laundry detergent in cents after the discount from the triple coupon? Let's sort the information in this problem. S represents the price of the box, B represents the size of the box in ounces, and the customer has a 30-cent discount coupon. Now, the value of this coupon will be tripled, or 30 times 3. Now we can determine the price of the box with the discounts. The price of the box is S minus 3 times 30. However, we're not finished. The problem asks for the price per ounce. This is represented by price divided by ounces. In this problem, the answer will be the price, or S minus 3 times 30, divided by B, or the size of the box in ounces. The correct answer is J. Problem 7. Let circle dot be an operation defined on the real numbers by C circle dot D equals C plus D divided by 3. Which of the following is or are true for all real numbers C, D, and F? This problem is asking us to play Let's Pretend. Pretend that the funny symbol, the circle with a dot between the C and the D, is defined by the mathematical operation C plus D divided by 3. Let's substitute some simple numbers to see how this definition works. Let C equal 2 and D equal 4, for instance. Then C circle dot D equals 2 plus 4, or 6, divided by 3, which gives us 2. To make our work easier, substitute numbers that make this expression an integer value if possible. Now, with these values, let's try each of the options. Roman numeral 1 states that C circle dot D equals D circle dot C. Does it? Well, we already know that C circle dot D equals 2 using the numbers that we picked. If we reverse C and D, we get the same value of 2. Thus, it seems that Roman numeral 1 works. To test Roman numeral 2, let's substitute another number for F. For instance, let's try 1. Now work out both sides. On the left side, we already know that 2 circle dot 4 equals 2. Then 2 circle dot 1 equals 2 plus 1 divided by 3, or 1. On the right side, work the parentheses first. 4 circle dot 1 equals 4 plus 1 divided by 3, or 5/3. Then 2 circle dot 5/3 equals 2 plus 5/3 divided by 3, or 11/3 divided by 3, or 11 divided by 9. As we can see, the two sides of Roman numeral 2 are not equal. Thus, Roman numeral 2 does not work. Now, since 1 works and 2 doesn't, we know the correct answer has to be A. Options B, D, and E are eliminated because they contain Roman numeral 2. Option C won't work because we know that 1 works. Now, just to be sure, let's work Roman numeral 3. Let's use F equals 1. 0 circle dot F equals 0 circle dot 1. This equals 0 plus 1 divided by 3, or 1/3. Now, 1/3 does not equal 0. The only expression that is true for all real numbers is Roman numeral 1 only, or answer A. Problem 8. In 4 games, Kate scored U points in the first game, 2 U points in the second game, and U plus 2 points in the last 2 games. Which of the following expressions best represents the total number of points Kate scored in all 4 games? Let's set up a table representing the 4 games that Kate played and the point value for each game. In the first game, Kate had U points. In the second game, 2 U points. And in the last 2 games, U plus 2 points for each game. Now, if we add like terms, we should get 5U plus 4 points. Thus, the correct answer is K. Problem 9. If x squared minus 4dx equals 12d squared, what are the 2 solutions for x in terms of d? If we factor this equation, it will be easier to solve for the 2 values of x. Let's rearrange terms in the equation to make this factoring possible. Subtract a negative 12d squared from both sides. Now we have x squared minus 4dx minus 12d squared equals 0. Now we can factor this equation. We know that x times x equals x squared. Now we must ask ourselves what 2 numbers will give us negative 12d squared when multiplied together and negative 4dx when added. Let's look at the answer options for possibilities. In this problem, a positive 2d and a negative 6d will work. Why? Positive 2d times negative 6d equals 12d squared. For the middle term, a positive 2dx plus a negative 6dx add to a negative 4dx. Now we can set each factor equal to 0 and solve. X plus 2d equals 0, or x equals negative 2d. X minus 6d equals 0, or x equals 6d. Thus, x could be either negative 2d or a positive 6d. The correct answer is D. Problem 10. For all x, which of the following is a factor of 8x squared plus 2x minus 3 equals 0? Once again, we need to factor this equation. This time, let's use the answer options to help us factor. For instance, let's try option F. Let x minus 3 be one factor. Then the other factor would have to be 8x plus 1 to get 8x squared and minus 3. But does this work? No, it doesn't, because the middle term is negative 23x and not plus 2x. So let's try the next option. Let's try 2x minus 1. The other factor would have to be 4x plus 3. Now, do the middle terms work? Yes, they do. Negative 4x and positive 6x equal 2x. The correct answer is G. Problem 11. If the lengths of adjacent sides of a rectangular field are represented by 3x minus 2 and 2x squared plus 4 units, respectively, for some value of x, then which of the following expressions represents the area in square units of the field? Let's draw a rectangle. The length of one side can be represented by the expression 3x minus 2, while the length of the other side is represented by 2x squared plus 4. The area of a rectangle is calculated by multiplying the length times the width. What makes this problem difficult is that the length and width are expressed in terms of variables and not numbers. Let's set up the factors and expand the expression. 3x times 2x squared equals 6x cubed. Negative 2 times 4 equals negative 8. Negative 2 times 2x squared equals negative 4x squared. 3x times 4 equals 12x. Putting the variables in order according to powers of x gives us 6x cubed minus 4x squared plus 12x minus 8. Answer C is the expression that represents the sum of these variables. Problem 12. If 8x squared minus b equals bx plus 1 times 4x minus 2, what is the value of b? One way to solve this problem is to recognize that the first term of the polynomial, 8x squared, is obtained by multiplying bx times 4x. The result, 4bx squared, has to equal 8x squared. The only value of b that works is 2. Thus, the factored expression is 2x plus 1 times 4x minus 2. Let's expand the factors to double-check our result. 8x squared plus 4x minus 2. These terms simplify to 8x squared minus 2. Thus, b equals 2 is the correct value. The correct answer is H. Problem 13. What is the smallest integer x satisfying the condition that x minus the square root of 3 is positive? The square root of 3 is a little over 1 by estimation, or equal to 1.73 to 2 decimal places using a calculator. This problem wants us to solve for the smallest integer value of x that will make this expression positive. Let's try the answer options. 1 minus the square root of 3 is negative. This doesn't work. 2 minus the square root of 3 is a positive 0.27 approximately. As you can see, the other answer options also give us positive values. 2, however, is the smallest integer in this list. Thus, the correct answer is B. Problem 14. The equation 1/2 x minus 2/3 equals 1/2 plus 2/3 x has only one solution. What is this solution? Let's eliminate the fractions by multiplying both sides by a common denominator. The least common denominator of 2 and 3 is 6. Let's multiply the left side by 6. 6 times 1/2 x equals 3x. 6 times negative 2/3 equals negative 4. Now multiply the right side by 6. 6 times 1/2 equals 3, and 6 times 2/3 x equals 4x. Now collect like terms. subtract 3x from both sides, and subtract minus 3 from both sides. The final solution is x equals negative 7. The correct answer is F. Problem 15. The quadratic equation 6x squared equals 27x can be solved by factoring. Which of the following states the complete solution? Let's rearrange the terms so that the expression equals 0. Subtracting minus 27x from the right-hand side gives us the following equation. 6x squared minus 27x equals 0. Now factor this expression. Look for the largest integer and the highest value of x that will divide into each expression. For this problem, 3 is the largest integer, and x is the highest value that can be factored. This factoring produces 3x times 2x minus 9 equals 0. Now we can set each factor equal to 0. 3x equals 0, or x equals 0. 2x minus 9 equals 0. Solving for x gives us 2x equals 9, and dividing by 2, we get x equals 9/2. There are two solutions to this expression. X equals 0 and x equals 9/2. The correct answer is C. Problem 16. If the equation x squared plus mx plus 2 equals 0 has two real solutions, both of which are negative integers, which of the following lists all possible values of m? Let's set up the two factors of this expression, x plus some number times x plus some other number. We know that the two numbers multiplied together have to equal positive 2, and that the two numbers are integers. There are only two possibilities. X plus 1 times x plus 2, or x minus 1 times x minus 2. The problem states, however, that the two solutions are negative integers. Which set of factors have negative integers as solutions? For the first set of factors, x equals either minus 1 or minus 2. For the second set, x equals plus 1 or plus 2. So the first set of factors are the ones we need. Expanding x plus 1 times x plus 2 gives us x squared plus 3x plus 2 equals 0. Thus, the value of m must be equal to 3. The correct answer is H. Problem 17. 2 plus 3 times the square root of 3 in parentheses times 4 minus 2 times the square root of 3 equals which of the following? Let's expand the factors. 2 times 4 equals 8. 3 times the square root of 3 times negative 2 times the square root of 3 equals negative 6 times 3, or negative 18. This is true because 3 times negative 2 equals negative 6, and the square root of 3 times the square root of 3 equals 3. Now, 3 times the square root of 3 times 4 equals 12 times the square root of 3. 2 times negative 2 times the square root of 3 equals negative 4 times the square root of 3. Now combine similar terms. 8 plus negative 18 equals negative 10, and 12 times the square root of 3 plus negative 4 times the square root of 3 equals 8 times the square root of 3. The correct answer is A. Problem 18. How many zeros are there in the integer representation of the product of 4 billion and 5 million? 4 billion is written as 4 followed by 9 zeros. 5 million is written as 5 followed by 6 zeros. The product of these two numbers will contain at least 15 zeros. However, 15 is not the final answer. Why? Well, multiplying 4 times 5 gives us 20, which adds one more zero to the final product. So the correct number of zeros is 16, or answer H. Entering the numbers correctly in a scientific calculator will also give you the correct answer in scientific notation. The product will be expressed as 2e16, which indicates that the product is the number 2 followed by 16 zeros. In either case, the correct answer is H. Problem 19. If the monthly mortgage payment, D dollars, on a house that cost H dollars is given by the formula D equals H divided by 200 minus 0.0005H plus 60, what is the monthly payment to the nearest dollar on a house that costs $100,000? This problem requires us to substitute the value 100,000 into the formula. Let's do it in steps. H divided by 200 becomes 100,000 divided by 200, or 500. 0.0005 times 100,000 equals 50. Thus, D equals 500 minus 50 plus 60, or 510. The correct answer is D. Problem 20. A given rectangle is represented by length L and width W. Tripling each of the dimensions, L and W, will increase the original area by what factor? Let's work this problem in two different ways. First, substitute numbers for the variables. Let the length equal 2 and the width equal 1, for instance. Then the area equals 2. Now triple each dimension. The length becomes 2 times 3, or 6, and the width becomes 1 times 3, or 3. The new area is 6 times 3, or 18. Thus the area has increased from 2 to 18. It has been multiplied by a factor of 9. Working the problem more abstractly also produces the same result. Writing the equation as area equals 3L times 3W gives the new area as 9 times LW. Thus, the original area has increased by a factor of 9. In either case, the correct answer is H. Problem 21. The expression A minus B in parentheses divided by B has the value of 0 if and only if a fraction can have the value of 0 only if the numerator equals 0, as in 0 divided by b. The denominator of a fraction cannot equal 0 because division by 0 is undefined. For this expression to have the value of 0, a minus b must equal 0, and b cannot equal 0. The option that specifies these two conditions is C. The correct answer is C. Problem 22. For which real values of n is 3n divided by 3 to the power 2 times n minus 4 defined? Expressions are undefined only when division by 0 is attempted. In this problem, the expression would be defined by all numbers except those that make the value of the denominator 0. Is the expression 3 to the power 2n minus 4 equal to 0 for any numbers? In other words, can we raise 3 to any power and get the value of 0? At first glance, we might be tempted to answer that 3 to the 0 power is 0. We might let 2n minus 4 equals 0 and solve for n equals 2. However, answer K is not correct. By definition, any number to the 0 power is equal to 1. Thus, 3 to the 0 power is 1. Consequently, there are no real numbers that will make the denominator equal to 0 in this expression. Thus, all real numbers will work. The correct answer is F. Problem 23. David has 3 sweaters, 2 pairs of pants, and 3 pairs of shoes that go together well in any combination. How many different outfits can David put together consisting of 1 sweater, 1 pair of pants, and 1 pair of shoes? The number of different outfits is calculated by multiplying the number of possibilities. The number of sweaters times the number of pairs of pants times the number of pairs of shoes. Specifically, 3 sweaters times 2 pairs of pants times 3 pairs of shoes equals 18. The number of different outfits totals 18. Now let's see why this works. For instance, let's label sweaters as A, B, C, pairs of pants as D and E, and pairs of shoes as F, G, and H. Thus, an outfit can consist of sweater A, pants D, and then either of the 3 pairs of shoes. Thus, sweater A with pants E also has 3 possibilities. That's a total of 6 different outfits with sweater A. In the same way, you could calculate 6 outfits with sweater B and 6 with sweater C. That's why the multiplication of possibilities works in this problem to produce the correct answer of E. Problem 24. Mark placed 6 yellow balls, 4 green balls, and 2 blue balls into a container. Mark then began to draw balls from the container at random. The first ball that Mark drew was yellow. The second ball that he drew was also yellow. These 2 yellow balls were not replaced in the container. What is the probability that the third ball that Mark draws will be yellow? Probabilities are expressed as a fraction between 0 and 1. For instance, if I wanted the probability of drawing a yellow ball on the first draw, this probability would be calculated as the number of yellow balls divided by the total number of possibilities, or 6 divided by 12. In this problem, however, 2 yellow balls are drawn and not replaced in the container. So, on the next draw, there are only 4 yellow balls left, and there are only 10 balls left. Thus, the probability of drawing a yellow ball would be 4 divided by 10, or reduced to 2/5. The correct answer is J. Problem 25. What is the largest possible product that can be formed by multiplying 3 different numbers chosen from -9, -2, 1, 3, and 5? At first glance, we might attempt to solve this problem by picking the 3 largest looking numbers, 5 and 3 and -9. The product of these 3 numbers looks like 135. However, the product is -135 since we're multiplying by -9. If we try only the 3 positive numbers, we get a product of 5 times 3 times 1, or 15. But is this the largest possible product? How about trying the two negative numbers multiplied by a large positive number? In this case, negative 9 times negative 2 times positive 5 equals a positive 90. This is our largest product. The correct answer is B. Problem 26. Both L and M are positive integers, and the smallest positive integer that is divisible by both L and M is 45. The greatest common factor of L and M is 3. If L equals 15, then M equals what? Let's attack this problem by trying to eliminate answer options. The integer 45 has to be divisible by both L and M. We already know that L equals 15. Which of the integers in the answer options also divide into 45? The numbers 3, 5, 9, and 15 could be candidates for M, but not 25, since it doesn't divide evenly into 45. Option K is eliminated. Also, the greatest common factor of L and M is 3. This fact eliminates option G. The number 3 is not a factor of 5. This process leaves options F, H, or J, or the numbers 3, 9, or 15. The problem states that the number 45 is the smallest positive integer that is divisible by both L and M. Well, let's try the possibilities. Is 45 the smallest integer divisible by 3 and 15? No, it isn't. Both 15 and 30 are divisible by 3 and 15 and smaller than 45. Is 45 the smallest integer divisible by both 9 and 15? This looks like the answer. Let's try the last option. Is 45 the smallest integer divisible by 15 and 15? This doesn't work. Both 15 and 30 are divisible by 15 and smaller than 45. By a process of working our way through the problem, we have determined that the correct answer is H. Problem 27. If r minus s in parentheses squared equals 9, and r times s equals 18, then r squared plus s squared equals which of the following? We can work this problem two ways. First, let's expand the expression r minus s in parentheses squared. The expanded form is r squared minus 2rs plus s squared equals 9. From the problem, we know that r times s equals 18, so let's substitute. Now we have r squared plus s squared minus 2 times 18 equals 9. Well, 2 times 18 is 36. Adding this expression to both sides gives the answer. R squared plus s squared equals 45. There's a second way to approach this problem. We need two numbers whose difference squared is 9, or whose difference is 3. Also, the two numbers have to multiply to 18. Can you think of two integers that meet these conditions? Well, 6 and 3 are possible. 6 squared plus 3 squared also gives us the correct answer of 45. In either case, the correct answer is E. Problem 28. Which of the following calculations will yield an even integer for any integer g? Let's substitute some numbers. Let g equal 1, an odd number, and then let g equal 2, an even number. For g equals to 1, the options are as follows. G squared is 1, 2g squared is 2, 3g squared is 3, 2g squared plus 1 is 3, and 3g squared plus 1 is 4. Options F, H, and J are eliminated because we did not get an even integer as the problem requested when we substituted the number 1. Now let G equal 2. Option G is now equal to 8, and option K is equal to 13. Option K is eliminated. The correct answer is G. Problem 29. If D is a positive integer that divides both 68 and 85, but divides neither 10 nor 15, what would you get when you add the digits in D? Our first problem is to find a positive integer that divides both 68 and 85, but does not divide 10 or 15. Let's break 68 into prime factors. 68 equals 2 times 34, which is 2 times 2 times 17. Also, 85 is 5 times 17. One common factor of both 68 and 85 is 17. Now, 17 does not divide 10 or 15. Thus, it appears that D must be equal to 17. But we're not finished with the problem. The sum of the digits in D is 1 plus 7 or 8. The correct answer is E. Problem 30. Tony drove 400 miles at 55 miles per hour. How long did Tony's drive take to the nearest tenth of an hour? The solution to this problem requires knowledge of the following formula. Distance equals rate or speed times time. Or the formula can be rearranged to solve for rate. Rate equals distance divided by time. Or it can be rearranged to solve for time. Time equals distance divided by rate. In this problem, we need to solve for time. Let's substitute the values into the equation. Time equals distance, or 400 miles, divided by rate, or 55 miles per hour. Dividing 400 by 55 gives us the value of 7.2727 repeating, or when rounded to the nearest tenth, the correct answer of 7.3. Thus, the correct answer is K. Problem 31. Katie can walk 5 miles in T minutes. At that pace, how many minutes would it take her to walk 9 miles? This looks like it might be a problem using the distance formula. However, using ratios will make the solution much easier. Set up the equation as follows. 5 miles is to T minutes, as 9 miles is to how many minutes? Let's solve the equation. By cross-multiplying, we get 5x equals 9t. Dividing both sides by 5 gives us the final answer. X equals 9t divided by 5. The correct answer is E. Problem 32. The square root of x minus 7 is a real number if and only if. For this expression to be a real number means that it must not be imaginary. Imaginary numbers are produced by taking the square roots of negative numbers. This expression will be imaginary if a value of x makes the expression x minus 7 negative. Thus, the expression will be real only if the value of x makes the expression x minus 7 equal to or greater than 0. Solving this inequality gives us the following. X is greater than or equal to 7. The correct answer is F. Any values greater than or equal to 7 will make the expression real. Problem 33. What is the smallest number greater than 1 that, when divided by 2, 3, 4, or 5, leaves a remainder of 1 in each case? A remainder is the whole number left over in the process of long division. For instance, let's divide answer option A, 7, by 2. 2 divides into 7 3 times with 1 as a remainder. If we divide 7 by 3, we also have 1 as a remainder. But 7 divided by 4 leaves a remainder of 3. So option A doesn't work. Let's continue this process with the other options. 21 divided by 3 leaves a remainder of 0, so that doesn't work. 31 divided by 4 leaves a remainder of 3, so that doesn't work. 61, however, leaves a remainder of 1 when divided by 2, 3, 4, and 5. So 61 is the smallest number. The correct answer is D.
Before Dr. Smith begins his discussion of problems related to intermediate algebra and coordinate geometry, you should review the definitions and facts contained in the workbook. When you're finished, play the videotape.
Problem 34. Which of the following expresses all and only the values of x that satisfy the expression the absolute value of 4x plus 2 is less than 1? Absolute value inequalities usually have a range of solutions. For instance, let's first solve the positive inequality 4x plus 2 is less than 1. Subtract 2 from both sides, then 4x is less than negative 1. Divide both sides by 4. X is less than negative 1/4. However, values that satisfy the absolute value of negative 4x plus 2 is less than 1 will also work. So let's solve this negative inequality. Clear parentheses. Negative 4x minus 2 is less than 1. Add 2 to both sides. Negative 4x is less than 3. Divide both sides by negative 4, and remember to reverse the sign of the inequality when dividing by a negative number. Thus, x is greater than negative 3/4. Putting both solutions together gives us the correct answer, J. The value of x is less than negative 1/4 and greater than negative 3/4. Problem 35. Which of the following is a graph of 3 is less than or equal to x? Don't be confused by the way this inequality is written. It states that 3 is less than or equal to x. This is the same as saying that x is greater than or equal to 3. So the answer has to be either option A or B. What's the difference between these two options? The open circle on a line graph indicates that that value is not included. Thus, option A is the graph of the expression x is greater than 3. The closed circle indicates that the value is included. In this problem, answer B is the correct graph of x is greater than or equal to 3. Problem 36. Given that the absolute value of 2x plus 3 is greater than or equal to 11, what is the largest set of negative numbers included in the solution set of this inequality? This inequality needs to be solved only for negative number solutions. For instance, the absolute value of negative 11 is greater than or equal to 11. The absolute value of negative 12 is greater than or equal to 11, and so forth. To solve this inequality, we need to find values of x that make the expression 2x plus 3 greater than or equal to 11. So first, let's clear parentheses. Negative 2x minus 3 is greater than or equal to 11. Add 3 to both sides. Negative 2x is greater than or equal to 14. Finally, divide both sides by negative 2, and remember to reverse the sign of inequality. The final answer is x is less than or equal to -7. This answer corresponds to option H. Problem 37. If c to the power 2c minus 2 equals 9 to the power d minus 1, and c equals 3, what is the value of d? First, let's substitute the value of 3 for c into the left side. This substitution gives us 3 to the 4th power, which is 81. Thus, 81 equals 9 to some power. It should be easy to recognize that 9 squared equals 81. Thus, d minus 1 must equal 2. Solving for d gives us a value of 3, or answer D. Problem 38. If m equals 7 plus the square root of 2, and n equals 7 minus the square root of 2, which of the following numbers must be rational? 1, m times n, 2, m plus n, 3, m divided by n. A rational number can be expressed as the ratio of two integers. An irrational number, like the square root of 2, cannot be expressed as such a ratio. Let's do each of the operations suggested in Roman numerals 1, 2, and 3. Let's start with Roman numeral 2, since this addition is easy to calculate. The sum of m plus n gives us 14. The positive and negative square roots of 2 cancel each other out. Now, this sum is definitely rational. We know that Roman numeral 2 works. This knowledge eliminates answer options F and H. Let's calculate the product m times n. Expanding this expression gives us 7 times 7, or 49. Now notice that the middle terms cancel, and the positive square root of 2 times the negative square root of 2 gives us a -2. The product mn has a value of 47, which is rational. So Roman numerals 1 and 2 work. This eliminates option G. Now finally, let's divide m by n. To remove the radical in the denominator, multiply both numerator and denominator by 7 plus the square root of 2. We already know that the denominator would equal 47. We calculate this product in evaluating Roman numeral 1. The numerator, however, is not rational. The middle terms don't cancel, and we have an expression with values of the square root of 2. If you use a calculator to divide m by n, the result should be 1.506361,847, and so on, a non-repeating decimal. This result also indicates that the expression is not rational. Roman numeral 3 doesn't work. Thus, the correct answer is J. Only 1 and 2 are rational. Problem 39. What is the y-intercept of the line determined by the equation 5x plus 2y plus 4 equals 0? The slope-intercept form of the equation of a straight line is as follows. Y equals mx plus b, where m is the slope and b is the y-intercept. Let's rearrange this equation into this form. Subtract negative 5x and negative 4 from the left-hand side to produce 2y equals negative 5x minus 4. Now, divide both sides by 2. Y equals negative 5/2 x minus 2. The y-intercept is negative 2. The correct answer is B. Problem 40. Which of the following is the slope-intercept form of the equation of the line that is parallel to the line y equals 1/2 x plus 3, in the standard xy coordinate plane, and that also contains the point 0, 5. Parallel lines have equal slopes. The equation of the line given in this problem, y equals 1/2 x plus 3, is already in slope-intercept form. Thus, the slope of this line is 1/2. Looking at the answer options, only options G and H have the correct slope of 1/2. The line also has to contain the point 0, 5. If we graph this point, we see that the y-intercept is 5. Thus, the correct equation will have a slope of 1/2 and a y-intercept of 5. The equation in option H is correct. Y equals 1/2 x plus 5. The correct answer is H. Problem 41. As shown in the figure below, the base of a ramp is d feet long. The slope of the ramp, rise divided by run, is c, where c is greater than 0. Which of the following expressions gives the height of the ramp in feet? In this problem, the base of the ramp is the same as the run, and the height is the same as the rise. As the problem states, the slope of a line is defined by rise divided by run. The slope of this particular ramp is c. Let's substitute our known values into this formula. Slope, or c, equals rise, which is unknown, divided by run, which has the value d. Cross-multiply the equation. The rise, or height, equals c times d. The correct answer is A. Problem 42. A map is laid out in the standard xy coordinate plane. How long in units is a train's path on the map as the train travels along a straight track from town A, located at 16-7, to town B, located at 10-11? The solution to this problem requires knowledge of the formula for the distance between 2 points. The distance between 2 points is calculated by squaring the difference between x coordinates, squaring the difference between the y coordinates, and then taking the square root of the sum of these two squares. In this problem, the square difference between the x coordinates is 10 minus 16 squared, or 36. The square difference between the y coordinates is 11 minus 7 squared, or 16. The distance is the square root of 52. If we break 52 into the factors 4 times 13, then the square root of 4 can be factored from the expression. The final answer for the distance is 2 times the square root of 13, or answer K. Problem 43. What is the greatest y-coordinate among all points on the circle x plus 5 squared plus y minus 6 squared equals 4? The standard equation for a circle is x minus a squared plus y minus b squared equals r squared. The center of the circle is at AB with radius r. In this problem, the center of the circle is at minus 5 and 6 with a radius of 2. The problem wants us to solve for the greatest y-coordinate on this circle. If we sketch the circle and draw a radius from the center parallel to the y-axis, we can see that the greatest y-coordinate is a distance of 2 from the center of the circle. This y-coordinate has a value of 6 plus 2, or 8. The correct answer is E. Problem 44. Which of the following is a simplified version of 2x plus 1 divided by x minus x plus 3 divided by 3x valid whenever x is not equal to 0. To add or subtract fractions, we must first obtain a common denominator. This is also true when the fractions are composed of variables. What is a common denominator for x and 3x? The simplest common denominator is 3x. Using this denominator, we have only to transform the expression 2x plus 1 divided by x. Multiply the numerator and denominator by 3 to obtain 6x plus 3 divided by 3x. Now that we have a common denominator, we can subtract the fractions by subtracting the numerators. Be sure to clear parentheses correctly. 6x plus 3 minus x minus 3 gives us 5x divided by 3x. Cancel the x's, and the final answer is 5 divided by 3. The correct answer is K. Problem 45. For all positive C and all positive D, 1 divided by C plus 1 divided by D, all divided by 1 over C minus 1 over D, equals which of the following? To add or subtract fractions, we need a common denominator. In this problem, C times D can be used to simplify both the numerator and the denominator. To convert 1 divided by C to this denominator of CD, multiply by D over D to get D divided by CD. Multiply 1 over D by C over C to get C divided by CD. Now add the fractions in the numerator. D plus C over CD. Use the common denominator to simplify the fractions in the denominator. 1 divided by C becomes D divided by CD. 1 divided by D becomes C divided by CD. Add the fractions to get D minus C over CD. Now, to finish the problem, to divide by a fraction, invert and multiply by the denominator. In this case, the CD's cancel, so the final expression is D plus C divided by D minus C. The correct answer is B. Problem 46. A certain company maintains computers in constant proportion to the number of company employees. Last year, the company employed 300 people and had 240 computers. This year, the company added 50 new employees. To keep a constant proportion, how many new computers should the company purchase? A constant proportion means that the ratio of employees to computers remains the same. Let's set up the ratio of employees to computers. For the first year, the ratio is 300 employees to 240 computers. For the next year, it's 50 new employees, or 350 people. Remember to add 50 to 300, to an unknown amount of computers. Since the proportions are equal, let's set up an equation and then solve it. The equation is 300 divided by 240 equals 350 divided by x. Cross multiply to obtain 300x equals 350 times 240. Divide both sides by 300. Now cancel or use your calculator to solve for x. We can divide 50 into 300 and into 350, and then divide 6 into 240. Multiplying 7 times 40 gives us 280, which is the total number of computers for the 350 employees. The problem, however, wants us to solve for the number of new computers. Subtracting 240 from 280 gives us 40, or the number of new computers that are needed. The correct answer is F. Problem 47. In a certain elementary school, the ratio of left-handed students to right-handed students is 2 to 9. The school has 440 students. How many students are left-handed? Let's set up a chart to summarize this information. The ratio of left-handed students to right-handed students is 2 to 9. The total number of students has been divided into 2 parts for left-handed students and 9 parts for right-handed students. Adding 2 plus 9 gives us the total number of parts. In this case, the value is 11. Divide the total number of students, 440, by 11 to get 40. Thus, 1 part in this ratio equals 40. 2 parts equals 2 times 40, or 80, which is the total number of left-handed students. 9 parts equals 9 times 40, or 360, the total number of right-handed students. The problem asks for the number of left-handed students. Thus, the correct answer is C. Problem 48. For what values of x is x squared minus 2x plus 1 positive? One way to approach this problem is to factor this expression into x minus 1 times x minus 1. Looking at these factors and glancing at the answer options, we can see that substituting 1 gives us an answer of 0. So this expression is not positive using the number 1. How about substituting other numbers? If we let x equal 2, then the expression is equal to 1, a positive number. If we let x equal negative 1, then the expression is equal to 4, a positive number. Any values greater than 1 produce a positive value, as do any values less than 1. Thus, answer K is the best choice. All real numbers except 1 make this expression positive. Problem 49. If y equals 9 minus x plus 2 squared, for what value of x will y have its maximum value? One way to approach this problem is to substitute each of the answer options into this expression and then determine which produces the maximum value. The value of y is 5 when x equals negative 4, y equals 8 when x equals negative 3, y equals 9 when x equals negative 2, y equals 8 when x equals negative 1, and y equals 5 when x equals 0. Thus, when x equals negative 2, y has its maximum value. Now this makes sense looking at the expression. Y would be at its maximum when we subtract 0 from 9. A value of x equal to negative 2 essentially makes the expression x plus 2 squared equal to 0. Thus, the correct answer is C.
Before Dr. Smith begins his discussion of problems related to plane geometry and trigonometry, I suggest that you review the definitions and facts contained in the workbook. When you're finished, play the videotape.
Problem 50. Lines EF and GH intersect at point N. Line NM bisects angle GNF. What is the degree measure of angle Q? The only angle measurement that is given is angle ENH, which measures 160 degrees. What else do we know? Well, we know that vertical angles are equal. In this case, angle GNF is vertical to angle ENH, so it also measures 160 degrees. The problem states that line NM bisects angle GNF. From this fact, we know that the degree measure of angle Q is 1/2 the measure of angle GNF, or 1/2 of 160 degrees. Thus, angle Q measures 80 degrees. The correct answer is F. Problem 51. Two transversals intersect at point Q, a point between two parallel lines, R and S. The measures of angles are as marked on the figure below. What is the measure of angle OPQ? Some of the geometry problems on the ACT are not drawn to scale. That is, the angles might not be drawn accurately. Don't let this fact interfere with solving the problem. Just use the given information to solve the problem. Now, one way to solve this problem is to concentrate on the small triangle that contains angle OPQ. Since lines R and S are parallel, we know that alternate interior angles are equal. Let's put a new point on the figure. Call it R. Now angle ORQ is equal to 87 degrees. Since the sum of angles along a straight line equals 180 degrees, the measure of angle PRQ is 180 minus 87, or 93 degrees. Due to vertical angles, we know that angle RQP is equal to 42 degrees. We can use the fact that the sum of the angles of a triangle equal 180 degrees to finish this problem. Angle OPQ equals 180 degrees minus 93 minus 42, which leaves us 45 degrees. Thus, the correct answer is B. Problem 52. In triangle XYZ shown below, XY is parallel to TU, YZ equals 12, and other lengths and units are as marked. How many units long is UZ? Since XY is parallel to TU, we know that angle YXZ is equal to angle UTZ, and that angle XYZ is equal to angle TUZ. Thus, the two triangles, XYZ and TUZ, are congruent. The sides of congruent triangles are proportional. Thus, we can set up a ratio to help us solve this problem. For instance, the ratio of the side UZ to TU is proportional to sides YZ and XY. Substituting known values gives us the following equation. UZ divided by 5 equals 12 divided by 8. We can now cross multiply to solve for UZ. UZ equals 12 times 5 divided by 8. This gives us 60 divided by 8, or when reduced, 7 1/2. The correct answer is J. Problem 53. The base of an isosceles triangle is 6 units long, and each of the congruent sides is 5 units long. What is the area of the triangle in square units? Let's draw this isosceles triangle. The base is 6, and each of the two congruent sides is 5 units long. The formula for the area of a triangle is 1/2 base times height. Now, we already have the length of the base. Let's draw the height. The height is a line drawn from the opposite vertex perpendicular to the base. In an isosceles triangle, this height has a special property. It bisects the base. Thus, we now have a right triangle with one side equal to 3, the hypotenuse equal to 5, and one side unknown. We can use the Pythagorean theorem to solve for the height. This formula states that a squared plus b squared equals c squared. In this triangle, 3 squared plus the height squared equals 5 squared. This gives us 9 plus h squared equals 25. H squared equals 25 minus 9, or 16, and thus h equals 4. Now you might have also noticed that this is a 3, 4, 5 right triangle. Finally, substitute these values into the area formula. Area equals 1/2 base times height. Thus the area is 1/2 6 times 4, or 12. The correct answer is B. Problem 54. In the figure below, CD and EF intersect at G. The measure of angle CEG is 85 degrees, and the measure of angle GDF is 60 degrees. What is the measure of angle EGC? Lines DF and EC look like they're parallel, and we're tempted to make angle CEG equal to angle GDF, or 60 degrees, and then solve for angle EGC and get 35 degrees. However, the problem does not state that lines DF and EC are parallel. We cannot assume this fact. Thus, if the lines were parallel, angle EGC would be equal to 35 degrees. Suppose, however, that line DF was perpendicular to EF. Then angle EGC would equal 30 degrees. Thus, it appears that answer option K is the best option. Angle EGC cannot be determined from the given information. The correct answer is K. Problem 55. Two 30, 60, 90 degree triangles are shown below. The hypotenuse of the larger triangle is 24 inches long. If the perimeter of the larger triangle is 4 times that of the smaller triangle, how many inches long is the shortest of the 6 sides? This problem requires that we know the measurements of the sides of a 30, 60, 90 degree right triangle. In its simplest form, the measurements are 1, square root of 3, and 2, with these measurements corresponding to the 30, 60, 90 degree angles. Both triangles are 30, 60, 90. Therefore, the triangles are congruent and the sides are proportional. If the perimeter of the larger triangle is 4 times that of the smaller one, then the sides of the larger triangle are 4 times the length of the sides of the smaller triangle. The hypotenuse of the larger triangle is 24. Thus, the hypotenuse of the smaller triangle is 24 divided by 4, or 6. Since the problem requires the length of the shortest side, let's focus on the side measurements of the smaller triangle. Remember our basic triangle measurements. The 30 degree side is 1, and the hypotenuse is 2. In this case, the hypotenuse is 6, so the 30 degree side must be 3, and the 60 degree side is 3 times square root of 3. Thus, in this triangle, the shortest side is 3. The correct answer is E. Problem 56. In the figure below, all angles are right angles, and distances are as marked in inches. A straight line drawn from point A to point F would be how many inches long? Let's draw the line from A to F. At this point, this problem doesn't appear easy to solve. The line AF cuts across all the lines and the right angles and doesn't appear to be part of any triangle. There's a larger right triangle, however, hidden in this problem. Did you see it? Let's extend the line from AB and drop a perpendicular line from F to meet this extended line. Now AF is the hypotenuse of this larger right triangle. Do we know the lengths of the sides of this triangle? Well, yes, we do. Since CD is 4 and EF is 2, the length of the base of the larger right triangle is 6 plus 4 plus 2, or 12. Since BC is 3 and DE is 2, the height of this right triangle is 5. We can now use the Pythagorean theorem to solve for AF. The Pythagorean theorem states that a squared plus b squared equals c squared. Substituting values, we have 12 squared plus 5 squared equals AF squared. 144 plus 25 equals 169. And the square root of 169 is 13. Thus, the length of AF is 13. Answer G is correct. Problem 57. One side of a right isosceles triangle is 8 times the square root of 2 centimeters long. Which of the following could be the lengths of the other two sides in centimeters? A right isosceles triangle is the same thing as a 45, 45, 90-degree right triangle. The side measurements in this type of triangle, in their simplest form, are 1, 1, and the square root of 2, with the equal legs of the right triangle equal to 1, and the hypotenuse equal to the square root of 2. Let's draw another isosceles right triangle. The problem states that one side of this triangle has the measurement 8 times the square root of 2. We don't know, however, if this measurement corresponds to the leg of the triangle or to the hypotenuse. Let's work both cases. If 8 times the square root of 2 is a leg, then the other leg is also 8 times the square root of 2, and the hypotenuse would be 8 times the square root of 2 times the square root of 2. Why? Look at the basic 45, 45, 90-degree triangle. The hypotenuse is the square root of 2 times the length of a side of 1. In this problem, the hypotenuse is 8 times 2, or 16. We found that the lengths of the other two sides could be 8 times the square root of 2 and 16. Is this one of the answer options? Well, yes, it corresponds to answer D. So this is probably the correct answer. But let's work the other situation just to be sure. Let 8 times the square root of 2 be the hypotenuse. Then the length of the side would be 8 times the square root of 2 divided by the square root of 2, or 8. This triangle would have measurements of 8, 8, and 8 times the square root of 2. These measurements, though, 8 and 8, however, are not represented in the answer options. Thus, answer D is correct. Problem 58. In her elementary school class, Tammy was working on a craft project with construction paper. She wanted to cover an 8-inch by 12-inch rectangular piece of blue paper with 2-inch by 2-inch red squares. How many red squares does Tammy need to cover the blue piece of paper with one layer of red construction paper squares? Let's draw the larger rectangle with measurements 8 by 12. Within this rectangle, let's draw one of the smaller squares measuring 2 by 2. Now, how many squares are needed to cover the larger rectangle? Well, let's count. Proceeding along the length, we would need 6 of these squares to cover a length of 12. To cover a width of 8, we would need 4 squares. Thus, the total number of squares would be the product of 6 times 4, or 24. There's another way to solve this problem. We could calculate the area of the rectangle. Area equals length times width, or 12 times 8 equals 96. Then we could calculate the area of the square. area equals side squared, or 2 times 2 equals 4. To find how many squares are needed to cover the area of the rectangle, divide the area of the rectangle, 96, by the area of the square, 4. The correct answer, once again, is 24, which corresponds to answer option J. Problem 59. A square has an area of 32.7 square centimeters. If P is the side length of the square in centimeters, then P must lie between which two consecutive integers? Let's recall the formula for the area of a square. Area equals side squared. If the area of the square is 32.7, then a side P is the square root of 32.7. Using a calculator, the square root of 32.7 is 5.718, and so on. Or without a calculator, we could quickly estimate that the square root of 32.7 is somewhere between 5, because 5 squared is 25, and 6, because 6 squared is 36. In either case, the correct answer is A. Problem 60. As depicted in the figure below, XZ is tangent to the circle at point Z. The measure of angle XYO is 130 degrees. If the center of the circle is at O, what is the degree measure of arc NZ? It's important to realize that the degree measure of arc NZ corresponds to the degree measure of angle YOZ. If we know YOZ, then we know arc NZ. Angle YOZ is one of the angles in the triangle YOZ. Do we have enough information to calculate the degree measure of this angle? Yes, we do. If angle XYO is 130 degrees, then angle OYZ has to be 180 degrees minus 130 degrees, or 50 degrees. And if line XZ is tangent to the circle at point Z, then angle OZY is 90 degrees. Why? Well, remember, a tangent line to a circle forms a 90-degree angle. We can now calculate the degree measure of angle YOZ. YOZ equals 180 degrees minus 50 degrees minus 90 degrees, or YOZ equals 40 degrees. Thus, arc NZ also has a degree measure of 40 degrees. The correct answer is K. Problem 61. A circular garden has a diameter of 30 feet and has a brick walkway around it that is 2 feet wide, as is depicted below. What is the area of the walkway in square feet? To find the area of the walkway, let's find the area of the larger circle and then subtract the area of the smaller one from it. The remaining area has to be the area of the walkway. The formula for the area of a circle is as follows. Area equals pi r squared. The radius of the smaller circle is the diameter divided by 2, or 30 divided by 2, or 15. The area is pi times 15 squared, or 225 pi. Now, what is the diameter of the larger circle? Let's be careful. The walkway extends 2 feet on either side of the smaller circle. So the diameter of the larger circle is 30 feet plus 2 feet plus 2 feet, or 34 feet. The radius, therefore, is 17 feet. The area of the larger circle is pi times 17 squared, or 289 pi. Subtract to find the area of the walkway. 289 pi minus 225 pi equals 64 pi. The correct answer is D. Problem 62. In the diagram below, for the right triangle DEF, DE is 6 units long, and EF is 8 units long. What is the area in square units of rectangle DFGH? The area of a rectangle equals length times width. In this rectangle, we already have the length of side DH, 15 units. To calculate the area, we need the length of side DF. DF is the hypotenuse of right triangle DEF. We can use the Pythagorean theorem to solve for DF. In this case, a squared or 6 squared plus b squared or 8 squared equals c squared, or DF squared. 36 plus 64 equals 100. DF equals the square root of 100, or 10. Thus, the area of the rectangle is 15 times 10, or 150. Once again, don't worry that the figure is not drawn to scale. Just perform the correct calculations using the information given. The correct answer is K. Problem 63. In the figure below, the rectangle PQNO is contained in square LMNO. If isosceles triangle RNO divides PQ into 3 equal segments, what is the ratio of the widths of these rectangles? That is, PO to LO. Let the side of square LMNO equal 1 unit. We know that R is the midpoint of side LM. Why? Well, LO equals MN and RN equals RO. This makes triangles LOR and MRN congruent. So side LR equals side RM. Using a length of 1 for LM, we know that LR equals 1/2 and RM equals 1/2. Since PQ is divided into 3 equal segments, then PS equals ST equals TQ, all of which are equal to 1 divided by 3, or 1/3. Now notice that triangles LOR and POS are also congruent. Sides are proportional and congruent triangles. Thus we can set up the following ratio. PO to LO equals PS to LR. Substituting 1/3 for PS and 1/2 for LR and dividing the fractions gives us 2/3. Thus the ratio of PO to LO is 2 to 3. The correct answer is D. Problem 64. The figure below shows a circle with center O inscribed in triangle STU, and Q is a point of tangency of the circle with line SU. If SQ is 5 units long and the radius of the circle is 2 inches in length, what is the length of SO in units? Let's draw the radius of the circle with the line OQ. Since Q is a point of tangency with the circle, angle SQO is 90 degrees. Thus we have a right triangle in this problem. We know the length of side SQ, it's 5 units. The length of OQ is 2 units. We can use the Pythagorean theorem to solve for the hypotenuse SO. Substituting into the Pythagorean theorem gives us a squared, or 2 squared, plus b squared, or 5 squared, equals to c squared, or SO squared. Solving, 25 plus 4, 29, equals SO squared, and SO equals the square root of 29. Let's look at the answer options. The square root of 29 is option J. Thus, the correct answer is J. Problem 65. Triangle EFG is depicted within the circle below. The center of the circle is point O. Angle measures and side lengths are given in the figure. What is the area of the circle in square units? The area of a circle is calculated by pi times the radius squared. Now, what is the radius of this circle? We will need to use the information provided in the right triangle to calculate the radius. This right triangle is a special case of a 45-45 90-degree right triangle. Side EF equals 4 times the square root of 2. so does side FG. In a 45-45 90-degree right triangle, the sides are in the ratio of 1 square root of 2. Thus, if a side equals 4 times the square root of 2, the hypotenuse equals the square root of 2 times the side. In this problem, the hypotenuse, EG, equals 4 times square root of 2 times the square root of 2, or 4 times 2, or 8. The diameter of the circle, EG, is thus equal to 8. The radius is 1/2 the diameter, or 4. Substituting a radius of 4 into the area formula gives us 4 squared, or 16 pi. The correct answer is C. Problem 66. The circle below is tangent to the rectangle at points A and B. DF equals 8, and other measurements are shown in units. What is the area of the shaded region in square units? Let's draw the diameter AB. Since the circle is tangent to the rectangle at points A and B, a new rectangle is formed, ABFE. Let's calculate the area of the shaded region by subtraction. Let's find the area of the small rectangle, ABFE, and subtract from it 1/2 the area of the circle. What remains will be the area of the shaded region. The area of the rectangle is calculated by multiplying length times width, or 4 times 3 for 12. The radius of the circle is equal to 2. The area is calculated by pi times the radius squared, or pi times 2 squared, or 4 pi. This is the area of the entire circle. Taking 1/2 of this area gives us 2 pi. Thus, the area of the shaded region is the area of the rectangle, 12, minus 1/2 the area of the circle, or 2 pi. This corresponds to answer K. Problem 67. The figure below shows a semicircle cut from a rectangle. Distances are given in inches. What is the area of the figure in inches? The area of this funny-looking figure can be calculated by subtraction. The area is equal to the area of the rectangle minus 1 semicircle. The area of the rectangle is calculated by length times width, or 13 times 7, or 91. What is the diameter of the semicircle? The length of the rectangle is 13. The diameter of the semicircle is equal to 13 minus 7, or 6. The radius would be 1/2 the diameter, or 3. The area of the semicircle would be 1/2 the area of the full circle. The area of the full circle is pi times radius squared, or pi times 3 squared, or 9 pi. The area of the semicircle is 1/2 of this, 4.5 pi. Thus, the area of the shaded figure is the area of the rectangle, or 91, minus the area of the semicircle, or 4.5 pi. The correct answer is A. Problem 68. In the figure below, what is the sine of angle T? The ACT requires that you know the definitions of the basic trigonometric relations. These definitions are as follows. Sine of angle T equals the opposite side divided by the hypotenuse. Cosine of angle T equals the adjacent side divided by the hypotenuse. And the tangent of angle T equals the opposite side divided by the adjacent side. In this problem, using angle T as our reference point, S is the adjacent side, T is the opposite side, and R is the hypotenuse. The sine of angle T, therefore, equals the opposite side divided by the hypotenuse, or T divided by R. The correct answer is F. Problem 69. If the value of x is greater than or equal to 0 degrees and less than or equal to 90 degrees, and cosine x equals 12 divided by 13, then tangent x equals which of the following? Most trigonometry problems on the ACT involve relationships in right triangles. Let's draw a right triangle. Let x be one of the acute angles. The definition of cosine is as follows. Cosine x equals the adjacent side divided by the hypotenuse. If cosine x equals 12 divided by 13, then in this right triangle the hypotenuse is 13 and the adjacent side is 12. To find the tangent of angle x, we need the value of the unknown side. Use the Pythagorean theorem to find this unknown side. A squared plus b squared equals c squared. In this triangle, side A equals 5. The definition of a tangent is as follows. Tangent of angle x equals the opposite side divided by the adjacent side. In this problem, we have found that the opposite side has a value of 5 and the adjacent side a value of 12. Thus, tangent x is equal to 5 divided by 12. The correct answer is B. Problem 70. For values of b where sine b, cosine b, and tangent b are all defined, cosine b times tangent b divided by sine b equals to which of the following? Let's substitute the definitions of cosine, sine, and tangent into this equation to help us simplify the problem. Cosine b equals the adjacent side divided by the hypotenuse. Tangent b equals the opposite side divided by the adjacent side. If we multiply these two quantities, we notice that the adjacent terms cancel, and we're left with opposite divided by the hypotenuse. Now in the denominator, sine b is represented by the opposite side divided by the hypotenuse. Notice that the numerator and the denominator are now the same. Thus, this expression reduces to 1. The correct answer is G.